when we talk about transformations of radicals, you guys, or of anything, we have to look at the base function. So when we looked at a parabola, we looked at the basic parabola, and then we moved it all over the place, which is fun. And then when we looked at a log function, we moved it, and an exponential, we moved it. And I told you transformations is going to be everywhere. It is. So we're looking at radical functions, and then we're going to move them, and then we're going to look at rationals next, and we're going to move them, and we're going to look at other functions and do some movement with that too. So transformations is everywhere. It's everywhere. The base radical function, the reason why I love this unit so much is it's really easy to figure out transformations, like a horizontal and vertical transformation with a radical, because your radical base graph starts at 0, 0. So no matter what stretch you have on there, stretches or reflections, that means you multiply by that value, right? When you multiply 0 by any value and 0 by any value, it basically stays 0, correct? So if this point moves anywhere, it's only moving by transformation. So if you want to know your horizontal and vertical translations with every other equation and graph we've ever done, you have to figure out the stretches first and reflections, take those off, and then see the translations, right? So it's way harder to actually come up with the equation on any other graph but a radical. Radicals are awesome because if this moves, that means you've had a vertical or a horizontal translation. Okay? So the base graph of a radical is square root x. Last year you dealt with radical functions, and you had to even state restrictions on a radical last year in grade 11. So anything that's underneath the square root sign has to be 0 or greater, right? It can't be less than 0 because you can't take the square root of a negative number, correct? So whenever you have a radical, you're going to state restrictions. Your restrictions are awesome because your restrictions then give you your domain. So if we took this one and we said x has to be greater than or equal to 0, it has to be because it's underneath the radical, correct? We have our domain. Then you base your range on what your domain is, okay? So because I have to have x values being 0 or greater, when I plug those in, my y values are also going to be 0 or greater. So that's why we get our range to be y is greater than or equal to 0. You need to understand radical and rational functions, the next two units, really well, so that when we do operations on functions, you can do them. They're easy because you know all this stuff, which is put into operation. The intercepts in domain and range suggest an endpoint at 0, 0, and no right endpoint. It keeps going on forever, okay? Now, what you have to realize is sometimes if we have a reflection in the x-axis, our range is going to be y is less than that value, correct? Because it's going to pop the whole graph below. If we have a reflection in the y-axis, our domain is going to be x is less than whatever the heck that value is, not greater anymore, right? So our reflections change these values. So if you have a, might want to write this as a little side note. Reflection in the y-axis, your domain becomes x such that x is less than or equal to whatever the value is, a number of some sort, whatever it is. You have to figure that out. If you have a reflection in the x-axis, your range is going to change to y such that y is less than or equal to a number. Okay? The graph is shaped like half of a parabola. The domain and range indicate that half the parabola is in the first quadrant for this one. And then we're going to deal with transforming radical functions. Base radical function y equals root x is transformed by changing the values of the parameters a, b, h, and k. So you're going to be changing a, b, h, and k. It's the same parameters as always. Get you your vertical stretch or reflection in the x, horizontal stretch, reflection in the y. Remember by 1 over b because you'd flip it. Horizontal translation h to the right in this case, and a vertical translation k up. So it's all the same transformations. Like they don't change, right, depending on the function. So this goes through and tells you everything that you know, just like you've done the whole time. It just means, hey, it's another transformation, nothing changes. So let's flip to the next page. Gave you a little rundown. So number 1, explain how to transform the graph of y equals square root x to obtain the graph of each function. State the domain and range in each case, show mapping notation, and graph the new graph on the Cartesian plane provided. So we have this here, right? You can leave it on this side. If it's with the variable, you flip it. If it's not with the variable, you keep it. Remember, we've used the same thing over and over and over. So we have a vertical stretch by a factor of what? Is it by 3 or a third? 3 or a third? 3, because it's not with the variable. 3 about the x-axis. Do we have a horizontal stretch? Because we have to do stretches, reflections, translations. Do we have a horizontal stretch? Trick question. No, we don't. Do we have any reflections? Yes. We have a reflection in the what axis because it's with the x? Reflection in the y-axis. Do you see how they pulled the negative out? Remember, it's the same as every single thing. If you have a horizontal stretch or a reflection here, you have to pull that value out to get your horizontal translation. It hasn't changed the whole time. Remember how I told you on the diploma? It's rare if they have it written like this. They normally would have this written as square root of negative x minus 4, and you'd have to take the negative out, right? Okay. We have a vertical translation to up or down? Down, because it's not with the variable. You keep it. And a horizontal translation for left. Remember, mapping is if you have to move points. So if you draw a graph, right, you use mapping. Mapping, you do what you say. So our xy is going to become negative x minus 4, because we go 4 left. Our y is going to become 3y minus 2. So we move the original graph. The original graph is y equals root x, correct? You could punch that into your calculator, go to your table of values and draw it, or you can figure it out. Okay, if I pick x to be 0, root x is 0, so it's at 0, 0, which I told you it always starts at, right? Then I want to pick square roots to fill in here because it's easier. If I pick like root 2, I'm drawing a decimal, which is not very fun, correct? So I'm going to pick whole ones. So like root 1. Root 1 is 1, so my point's at 1, 1. The next one I'm going to pick is 4, because that'll give me my next one. The square root of 4 is 2, so I'm going to be at 4 and 2. And then I always pick 9 after that. Square root of 9 is 3, so I'm going to be at 9 and 3. So that's the base root x graph. And now we're going to do our transformations to it. So we have the point 0, 0. It's going to be negative 0 minus 4 is going to become negative 4. And 3 times 0 is 0, minus 2 is negative 2. Do you see how the stretches and reflections do absolutely nothing to that first point? Because you're multiplying by it. When you multiply 0 by anything, it doesn't do anything. So I'm going to go to negative 4 and negative 2. So if I had to draw the equation, it'd be really easy to get the translation, or if I had to make the equation, because I would know, oh, hey, I went 4 to the left and 2 down, because that's where this point went. A little more work when you get to actual values that aren't 0, 0. So if I plugged in 1, 1, I get negative 1 minus 4, so it becomes negative 5. And then 3 times 1, which is 3, minus 2 is 1. So 1, 1 moves to negative 5 and 1. Why are we going this way now? What the heck? It was going that way. Why are we going this way? Reflection in the y. So the graph was going this direction. It's now going to be going this direction, which means my domain is going to change, right? Okay, then I have 4, 2. Negative 4 minus 4 becomes negative 8. And then 3 times 2 is 6, minus 2 is 4. So now I'm at negative 8 and 4. Wow, it's sure getting taller. Oh, we have a vertical stretch by 3. It's stretching it vertically, right? And then negative 9 minus 4 gets too far off the graph, so I'm not going to change that point. What's my domain? lot of people say it's always x is greater than or equal to 0. You said that. I didn't say it's always that, right? If there's a reflection or translations, it totally changes it. So in this case, the domain is going to be x such that x is less than or equal to. It's less than or equal to because we had a reflection in the y-axis. When we have a reflection in the y-axis, our domain changes. X is less than or equal to negative 4. Our range is still going to be greater than or equal to because we didn't have a reflection in the x-axis. So it's going to be y is greater than or equal to negative 2. Y here. Okay? Can you guys try it for the next one? Don't forget to take the 4 out. This is not a horizontal translation to 12 to the right. It's not. Make sure you take that 4 out. Okay, so I'm going to first do y equals negative 2 square root 4 x minus 3 plus 5. So I have a vertical stretch by a factor of 2 about the x-axis because it's not with the y. So I keep it. Horizontal stretch by a factor of a quarter because it's with x about the y. The negative in front of a 2, is that a reflection in the x or a reflection in the y? Reflection in the x because it's not with the x. Vertical translation 5 up, and a horizontal translation 3 right. And our coordinate was xy becomes, there's a horizontal stretch, you multiply our x by that, so a quarter. There's no reflection in the y, so it's not negative. X. Move 3 right, so we're going to have to add 3. Vertical stretch by factor of 2, y. It's negative because it's a reflection in the x. And we move 5 up, so we add 5. Our original graph is at 0, 0, 1, 1, 4, 2, 9, 3. And that's the y equals square root function. So this is just going to move to 3 and 5. 0, 0 moves to 3 and 5 when you plug it in, because that's not going to affect it, nor is that. When you plug 1, 1 in, you're going to get a quarter plus 3. What's a quarter plus 3? 13 over 4? Yeah. I'm sure we'll find it. And negative 2 times 1 is negative 2 plus 3 is, or plus 5 is 3. So you get 3 and a quarter and 3. 3 and a quarter and 3. Then we have 4 and 2. 4 times a quarter is 1, plus 3 is 4. And then negative 2 plus 4 is a negative 4, plus 5 is 1. So we're at 4 and 1. And it's going down. Why is it going down? We had a reflection in the x-axis, which means my range is going to be less than or equal to, right? It's causing it to go down. And then 9 and 3. 9 times a quarter is 9 fourths, plus 3 is 12 fourths. 9 fourths plus 12 fourths. 21 over 4. Is it 21 over 4? Which is 5.5 and a quarter? Yes? No? So 5.25, because the other way is weird, right? And then negative 2 times 3 is negative 6, plus 5 is negative 1. So 5 and a quarter and negative 1. So my domain is going to stay greater than, because I didn't have a reflection in the y, and it's not a y. I just said y, and so I wrote y. So it's going to be x such that x is greater than or equal to 3. And your range is going to be y such that y is less than or equal to 5. Did you notice that these are based on just the translations? Right? I moved 3 to the right, I moved 5, because that initial stretches and reflections don't change that 0, 0, right? So your domain and range are completely based on your vertical translation and horizontal translation. Then flip over. Do these two. So we're going to get a vertical stretch by a factor of 4 about the x-axis. Horizontal stretch by a factor of a 5th about the y-axis. No reflections. Vertical translation 4 down. Horizontal translation 1 left. The coordinate goes from x, y to 1/5 x minus 1 and 4y minus 4. Your original points are 0, 0, 1, 1, 4, 2, 9, 3. Your new point is going to be at -1 and -4. And it's going to be in the same direction, right? Because I had no reflections. It's not going to go backwards. It's not going to go down. It's going to just look a little different, but the same direction. So if I have no reflections, my domain and range are both what? 0 or a number or a value. Are they greater than or equal to, or are they less than or equal to? If you have no reflections. Greater than. You have to remember to know all your rules backwards and forwards, right? Because in the diploma, what they do is they give you a whole bunch of variables and no numbers. So if you're someone who's like, well, I'll just plug in my calculator and look, you can't. There's no numbers, right? So we need to know that if it reflects in the y, our domain becomes less than or equal to. It becomes less than or equal to the what? The horizontal translation, right? And if we have a reflection in the x-axis, our range is less than or equal to the vertical translation, right? That's how you get your domain and range. So do we even need numbers? No, we could have letters and still fill it in. All right. What's our next point? Did anyone get it? 5 times 1/5 minus 1, -4/5 and 0. And then we'd have 4 times 1/5 is 4/5, so it's going to be -1/5. Oh, this is really condensed. -1/5 and 4. And then this is going to be 9/5 minus 1. So it's going to be 4/5 and 3 times 12 minus 4, 8. That's one crazy graph. So the domain is x such that x is greater than or equal to -1. And the range is y such that y is greater than or equal to -4. Now this one, without even doing the graph, if I just do the equation, y equals negative square root negative, thanks, calculator or computer, -3x plus 2. We have two negatives. We have a reflection in the x-axis. We have a reflection in the x-axis. That's going to make my range less than or equal to, right? Reflection in the y-axis is going to be my domain less than or equal to. So if I just do the domain and range just off of here, my domain is going to be x such that x is less than or equal to -2 XER, because it's based on my horizontal translation. And my range is going to be y such that y is less than or equal to 0 YER, because I have no vertical translation. Didn't have to graph it at all, and I could come up with those, right? Because your stretches and your stretches don't change anything on a domain and range, right? They change it on the graph, absolutely, but not on the domain and range. Your reflections change whether it's greater than to less than, right? And your translations are what gets your values for your domain and range. Okay? The last little bit of class